Tina slowly, slowly. We be working all day long, the push us bunny. We ain't playing no games, Sabatavi, Gani.
Good day, guys. I hope you are good. Today was doing the typical exam questions. So guys, here, without wasting more time, let's try to answer this question. Solve for theta. 3 cos theta minus 2 sin theta equals to 0. So whenever you are dealing with these guys, you must remember your identities, your quotient identities, your doubly angles, your compound angles. So we're given this equation, guys. So the first thing that I need to do here, I can see that this is cos. I cannot change cos. And this is sine. I cannot change sine. But if I divide sine by cos, I will get tan. So we know that the quotient identity says that sine theta over cos theta is equals to tan theta. So what I'm going to do here, guys, I'm going to transpose cos theta to that side. So I'm going to be left with negative 2 sine theta to theta minus cos minus 3 cos theta. So guys, if guys here we want to get tan, I have to divide both sides by a cos. So also on this side by cos, but at the same time, guys, we want to get rid of this coefficient, which is negative 2. Then I divide by negative 2 and negative 2. So here this 2 will cancel this one. This cos is going to cancel this cos. Now we are left with sine over cos. We know, guys, that sine over cos will give us a tan theta. Then this negative is going to cancel out, guys. Then we are going to be left with 3 over 2. Then we can find the reference angle. Remember what we said on the previous video. I'm going to say reference angle is equals to arc tan of 3 over 2. Then what do we get as our reference angle? So inverse of tan 3 over 2, we get 56,31 degrees. Can you see, guys, this tan is positive? So which means if it is positive, guys, we're going to get how many solutions? 2 solutions. So you need to ask yourself, where do we find tan positive? We find tan positive on which quadrant? Third quadrant. So I'm going to say quad 3. So quad 3, guys, we said that quad 3 for tan is 180 plus the reference angle plus the period of tan, which is k times 380 degrees. So I said, guys, you can use 360 if your teacher used 360, but you are going to do in different way. So I'm going to say here theta, because we're working with theta, is equal to 180 plus my reference angle, which is in this case is 56,31 degrees. Then I don't forget my period, which is 180 degrees, where k is the element of integers. So what do we get if we add 180? So this is 236,31 degrees plus a k 280 degrees, where k is the element of integers. So if I present my solutions, so I can say, therefore, my solutions, I have 56,31 degrees, then plus k to 360 degrees, 180 degrees, where k is the element of integers, or we have theta is equals to 236,31 degrees plus k to 180 degrees, where k is the element of integers. So these are your solution for the first question. So let's see the next question. What do we have? So we're given we have number 1 and number 2. Okay, so guys, for number 1, let's put it here. Hope that you can see. Let's drop it down. Okay, so number 1, guys, we have a tan alpha is equal to cos alpha. Right, I'm solving for alpha here. So if I'm solving for alpha, guys, can you see that I cannot change cos, but I can change tan into a quotient identity. So if I'm changing tan to become sine alpha over a cos alpha equals to cos alpha, right? So here guys, cos is divided by 1. Then you do your what? Your cross multiplication. So these guys are 1 times sine is going to be sine alpha. Then here cos times cos guys is going to give us cos squared alpha. Now remember your square identity, because we cannot change this sign, so we must change everything here to be in terms of sine in order for us to solve for alpha. So we can change this one. I'm going to drop sine alpha here, but I know that I can change a cos squared alpha, so to become 1 minus sine squared alpha. Understand? So now we can transpose this to that side. So if we transpose negative sine squared to this side, is going to be positive sine squared alpha, then plus sine alpha. Then if we transpose 1 to this side, it's going to be minus 1, then equals to 0. Understand, guys? This thing, guys, is the same as if we are having, this is your algebra. That's why I was saying you must remember your algebra. So this is the same as x squared plus x minus 1 equals to 0. Can you see that, guys? We don't have the factors here. So if you don't have the factors to write, what do? You go to your quadratic. So I'm going to use quadratic to solve to find the solutions here. So guys, the quadratic, it says x is equal to negative b plus or minus square root of b squared minus 4ac over 2a. So in this case, guys, we are not solving for x now. I'm solving for sine alpha. So in place of x, I'm going to put sine alpha. So this is sine alpha. It's got to negative b plus this b squared minus 4ac over 2a. Since we are doing grade 12, there's no mark for formula, guys. So this is sine alpha. So this one is going to be negative. Your b in this case, guys, is 1, because we see that we have 1 here and a 1 here. So your b in this case, guys, it's 1 plus or minus, which is 1 squared minus 4 into 1 and negative 1 over 2 into 1. So therefore my solutions for sine alpha will be equals to, we press your calculator, you can press your calculator, which is negative 1 plus 1 which is 5 over 2, right? We have these, guys. I will press it to 2 decimal. I have 0 comma, I will to 3 decimal 1 8, or sine alpha, then we can put minus there. This is a negative 1,618. All right. So guys, we don't stress ourselves about this one. There's no solution for this. So you just write here no solution, because we said on the previous video that sine and a cos must be in the interval of -1 and a +1. So that's your reason why we don't have a solution here, because if you can press your inverse here, you won't get the answer. It will say maths error. So we're gonna work with this one. Can you see, guys, here that this numerical value is positive? So this value is positive, which means I'm going to have 2 solutions here, guys. So I'm going to get the reference angle, so which is inverse of sine 0,618. So what do we get for your reference angle? Inverse of sine 0,618. So then we get 38,17 degrees. Then you need to ask yourself, where do we find sine positive? We find sine positive in which quadrant? Second quadrant. So I'm going to say 180 minus your reference angle, then plus the period. So the period of sine is 360 degrees. So I'm going to say quad 2. You can say, or you have now, we are solving for alpha. I'm going to say alpha 180 degrees minus your reference angle, which is 38,17 degrees. plus k to 360 degrees, where k is the element of integers. So what do you get? 180 minus this answer. So we get 141,83 degrees plus k to 360 degrees, where k is the element of integer. Remember guys, you must not forget your period, because if you forget your period, your answer will be incomplete. So you can conclude that alpha is equals to 38,17 degrees plus k to 360 degrees, where k is the element of integers, or alpha is equals to 141,83 degrees plus k to 360 degrees, where k is the element of integers. Understand? So let's try to attempt number 2 in this one. Remember guys, you can pause the video and try to attempt on your own and see what you get. So number 2 guys, we are given 2 sine alpha is equals to 5 sine 90 minus alpha. Guys, you can get easy marks here. Can you see that we cannot change sign? Then we drop it. If we don't change it, we have 5 here, but we have sine 90 minus, what do you think? You think of what? Your core function. If I see 90 tells me that sine must change the name to become what? Cos. Where do we find 90 minus? We find 90 minus on which quadrant? On the first quadrant. All the three ratios, they are what? Are positive. So this sign is going to change to become cos alpha. Right. Can you see now? This is given in the form of a sine alpha is equals to b sine cos alpha. This is the form. So which means I cannot change sine, I cannot change cos, but if I divide both sides by cos, I will get tan. So I'm going to divide by cos alpha, but we don't want this coefficient again. So then I have to divide by 2 both sides. So this 2 will cancel this, and this cos will cancel this. So we know that sine of a cos, guys, will give us a tan alpha, which is 5/2. Wow. Now this tan, guys, this numerical value is what? Is positive, which means we will have 2 solutions. So the first thing I'm going to do here, I'm going to write a reference angle. So your reference angle, guys, is going to be inverse of tan, which is 5/2. So what do you get? The inverse of tan 5 divided by 2, we get 68,20 degrees. Okay, so we go where tan is positive. Tan is positive here, guys, and we're working with tan, so your period is going to be 180 degrees. So I'm saying or quad 3. So I'm going to have as my reference angle, guys, I'm going to say theta is equal to 180 plus my reference angle. So I'm going to say alpha is equal to 180 plus your reference angle, which is 68,20, plus your period. We are working with tan, is going to be 180 degrees, where k is the element of integers. So what do you get? If we add 180, we get 248,20 degrees plus k 280 degrees, where k is the element of integer. This is the final solution, guys. We can conclude now that our solution is this one, which is 68,20 plus your period, which is k to 180 degrees, where k is the element of integers. Or this one was already written as a solution, but you can take it down again to 48,20 degrees plus k to 180 degrees, where k is the element of integers. Guys, you must not forget your period, because if you forget your period, your answer will be incomplete. I repeat. So let's take the last question. We will not finish it, we're gonna finish it on the next video. So this question is this one, guys, that involves your double angles now. So we're gonna take number one, solve for theta 2 sine 2 theta equals to 3 cos, right? So let's copy it down. We have a 2 sine 2 theta is equal to 3 cos theta. Okay, right. So guys, it's all about changing in trigonometry. It's all about changing the double angle, changing the compound angles, changing the co-ratios, changing the quotient identity, square identity. So guys, here can you see that we can change sine to theta, but we cannot change cos. So this one that we cannot change, I'm going to drop it, guys, because cos is cos. But if it was cos squared, I was going to be able to change it. So now I cannot change it. It's cos. So we come here, we have this coefficient. I'm gonna put my coefficient, and then I change what I see. We know that, guys, as sine 2, this is a double angle, so it's going to be 2 sine theta cos a theta. Can you see? Then we close the brackets. So this is okay, guys. Now we can see this is the same as 4 sine theta cos theta equals to 3 cos theta. So we're gonna transpose this 3 cos theta to this side. So I'm going to have 4 sine theta cos theta minus 3 cos theta, so equals to 0. Now it's all about doing your algebra, guys. It's more like if you are having x, y minus y equals to 0. So what you were going to do here, you were going to take out what is common, which is in this case is y. Then you will be left with inside x minus 1. So in this case, your y be equal to 0, or your x is going to be equal to 1. So here we can tell that, or we can see that cos is common. So I'm going to take cos theta outside. Then I have 4 sine theta minus 3 inside, which is equals to 0. So we can see that, guys, cos theta is equals to 0. So cos theta is equal to 0, or 4 sine theta minus 3 is equal to 0. So here, guys, it's all about doing your algebra. You will try to isolate sine theta. So I'm going to transpose this one to that side and divide by 4. So divide by 4 both sides. So I'm going to have sine theta equals to 3 over 4 here. So guys, we can find the solution here. So I'm going to find the angle here, which is for, if I'm working for cos theta is equal to 0 degrees, so I'm going to get the reference angle, guys. So if I want to find the reference angle here, guys, theta is going to be arc sine 0, which is 90 degrees, plus k to 360 degrees, where k is the element of integers. Then you need to ask yourself, where do we find cos positive? You go where you find cos positive. We find cos positive on which quadrant? Quadrant 4. So quadrant 4, I'm going to say theta is equal to 360 minus this reference angle, which is 90. So 360 minus 90, what do we have? Is 270. So we have 270 degrees plus k to 360 degrees, where k is the element of integers. Then we go to this one, guys. So we're working with now with sine theta is equals to 3 over 4. Can you see, guys, that this numerical value is positive? So if this numerical value is positive, which means I will have two solutions. So I will get the reference angle, guys. I will say a reference angle is equals to inverse of sine, which is 3 over 4. So in this case, inverse of sine 3 over 4 is 4860 degrees. So where do we find sine positive? We find sine positive on which quadrant? Second quadrant. So I'm going to say quad 2, which is x is equal to, we're working with theta. Theta is equals to 180 degrees minus your reference angle, which is 48,60, plus your period, which is k, to 360 degrees, where k is the element of integers. So 180 minus 48, 180 minus 48. What do we get? 131, guys. It's 131,41 degrees. So these are your solutions. So you can present them like therefore we have theta that is equals to 90 degrees plus a k to 360 degrees, where k is the element of integers, and we have theta, which is 270 plus k to 360 degrees, where k is equal to where k is the element of integers, and a theta, which is 48,60 plus k to 360 degrees, where k is the element of integers, and the theta, which is 131,41 to 360 degrees, where k is the element of integers. So are we together? Hope we are together, guys. So let's we're gonna continue with number 2 and number 3 and number 4 in the next video. Stay tuned, guys. You can try to attempt on your own. Thanks for watching. Thanks to be the part of the family. We really appreciate you. Thank you very much. If you didn't subscribe, please don't forget to subscribe. Don't forget to tell your friends about our YouTube channel. Thank you very much. See you on the next video.